Kinematics equations are used for motions that have constant acceleration. And I'm going to show you a really effective way to use the kinematics equations without making mistakes and staying organized. So the very first thing you want to do when you read your word problem is create a quick little table. You want to write down your givens on one side and your unknowns on the other side. It's called gunking. You're learning how to gunk in physics. So your goal here is to get 3 givens on this side, and then you'll have 2 unknowns, because there's 5 quantities. There's 5 quantities in kinematics equations. Okay, you have the initial velocity, v1, final velocity, v2, the acceleration, remember that has to be constant acceleration, time, and displacement. Okay, so in order to apply kinematics equations, you need 3 of these in your given, and you're going to put what you're trying to find in the unknown. So you only need 1 here. You only need 1 unknown, because also you can't find 2 unknowns using 1 equation. The only exception to this is if v1 and v2 are the same, because if you think about it, if you say like v1 is 10 meters per second and v2 is also 10 meters per second, that's the exact same thing as just saying the acceleration is 0. So if you have these 3 and these 2 are the same, that's the only situation where this doesn't work, so you would need a 4th, okay? Now, in terms of the equations that you're given, your physics class will likely give you 3 equations, the first being the final velocity equals the initial velocity plus acceleration times time. The displacement is equal to initial velocity times time plus 1/2 acceleration times time squared. And the third is 2 times acceleration times the displacement is equal to the final velocity squared minus the initial velocity squared. If you notice, these 3 equations don't work in every situation. Because let's say you have the initial velocity, the final velocity, and the time, and you're trying to find the displacement. What happens in that situation? You can't use the first equation because you don't have the acceleration. Whoops, messed up here. You can't use the second equation because you also don't have the acceleration in that one. And you can't use the third equation because you have acceleration there too. But we don't have acceleration, and we also don't have delta x. Okay, so how do we solve this? Well, you can actually expand these equations. You can derive 2 more, and if you do that, you will be able to apply these to any situation. I will go ahead and just give you the 2 equations, and then if you want to see the derivation for them, I'll go over it right after that. But if you don't want to see that, you can feel free to skip that part. So the 4th equation is going to be delta x equals 1/2 v1 plus v2 times t, and the 5th is delta x equals v2 times t minus 1/2 at squared. Okay, so you can see that the 5th one is very similar to the second one. You just have the final velocity here and a subtraction symbol instead. So how did we derive those 2? Well, if we rearrange the first equation, we can say that a is equal to v2 minus v1 divided by t. And now we have that in terms of a. Now if we rewrite the third equation, we can get it to a equals v2 squared minus v1 squared divided by 2 delta x. And now we can swap these 2 for each other, make them equal to each other. So you have v2 squared minus v1 squared divided by 2 delta x equals v2 minus v1 divided by t. Now we can cross multiply. v2 squared minus v1 squared times t equals 2 delta x v2 minus v1. Now we can isolate the delta x. I'll move it to the left side. And we can say that v2 squared minus v, keep messing up, that's supposed to be v1, v1 squared times t divided by 2 v2 minus v1. Now if you recognize this, this is just the same as v2 minus v1 times v2 plus v1. So what we're going to do is expand this out into this, and we're going to cancel out the minuses to leave us with the plus. I'm going to delete all of that real quick so I have room to write. So we're left with delta x is equal to, right, 1/2. You have the 1 over 2 right there. Then we canceled this out with another one in the numerator, and we were left with a v2 plus v1, and we still have the t there. And that's how we got our fourth equation. What about our fifth equation? This one's a bit simpler. We're starting with the first equation, and we're saying that v1 is equal to v2 minus at. Then we're saying that in our second equation, v1, if we rearrange it, we say that v1 is equal to delta x minus 1/2 at squared, and all of that is going to be divided by t. Okay, so we can substitute these. So we'll have, I'm going to cancel out one of these t's here. And I'm going to say that delta x divided by t minus 1/2 at is equal to v2 minus at. Now we'll add this to the other side. It's 1/2 of an at, so we'll have v2 minus a negative at plus 1/2 of an at is going to leave us with 1/2 of an at. And we still have a delta x over t here. Now we need to multiply this entire side by t, and we're left with delta x equals v2t minus 1/2 at squared, which is our fifth equation. That's it for the derivations. So how do we go through an actual problem now? So as I said before, we start by gunking. You'll read the problem, you'll write down your givens here and what you're looking for here, so you don't have to reread the whole problem if you forget something. Plus, if the problem is multiple parts, this makes it really easy. That way you don't have to like go back 3 parts to find what information was given in that part that you have to use for part 3 or whatnot. You can just look back at this table, and it's super simple, okay? Super simple. Once you identify which 3 givens you have and what you're looking for, you can just go through each one of these equations. Let's just go through them. Let's say you need an equation that doesn't have v1 because you have v2, you have a, you have t, and you have delta x. So you want an equation that doesn't have v1 in it. You just look through these, you say, oh, number 5 hat does not have v1 in it. So you can use that one for that situation. What about v2? Well, you can say, oh, well, number 2 doesn't have v2 in it. So you can use that one. What about a? Number 4 doesn't have a in it, so you could use that one. What about t? Number 3 doesn't have t in it, so you could use that one. What about delta x? Number 1. Okay, so each equation here can be applied to any kinematic situation. What you do once you identify what equation you're going to use is write that equation. Okay, not plug in yet, don't plug in yet. Just write your equation. Trust me, it will prevent so many errors, okay? And you'll still make mistakes, I guarantee it. I guarantee you still make mistakes even if you write the equation the way it is. Okay, but you'll make less mistakes, and that's what's important. Now, the real kicker here is that this only works in 1 dimension. If you're in 2 dimensions, you're going to have to do a little bit more than gunking, alright? You're going to have to hunk and vunk. You're going to create 2 tables instead. And again, trust me, it works. Okay, it works. Hunk and vunk. Alright, H for horizontal, V for vertical. And this is for the specific problems where you're saying like there's a cannon up here and it's launching a projectile through this path. Okay, so you have a horizontal component, that's vertical. I am dumb. You have a vertical component and a horizontal component. Okay, so if you're on Earth, the vertical acceleration is always going to be 9.8. Or in this case, since our positive v points upwards, we're going to have a negative 9.8 because the acceleration is going to be in the direction of the Earth, right? And in these types of problems, your horizontal acceleration is always going to be 0. Your v1 and v2 will always be the same. And remember, if you have the same v1 and v2, if those are the same value, then you need 4 things in your given section in order to solve it. So this situation wouldn't work. You need the delta x or the time. In most situations, you'll be given some sort of height here. You'll be given this height. You'll say like a 12-meter cliff or something like that, so you can say that the delta y in this situation, because it's in the y direction, right? The xy coordinate plane. Y is the vertical component of that. So the delta y, in this case, since we said 12 meters, we'll put 12 meters here. And if the cannon shoots straight out, I put it at an angle here, but if it shoots straight out like that, your vertical v1 is going to be 0 because there is no vertical component of the initial velocity. Is being shot straight horizontally. Right, so all of your v1 is going to be over here in the horizontal section. So it can get kind of confusing, which is why you need this table, okay? It helps. It works so well. And if you have these 3 quantities, 2 of those are already given to you basically, because if it's being shot straight out and you already know the gravitational acceleration, then all you need is 1 more. You can have that, you can have time, or you could have the final velocity. But in most cases, you'll be given this. You'll be given some initial velocity here, let's just say 10 meters per second, for example. And that's going to be the same for v2 because, remember, there's no acceleration, so the velocity is not going to change in the horizontal direction. So you're going to need something else here, too. Most of the time, you'll have to use this to find the time, and then you'll use the time over here to find the delta x. And that's what most of your two-dimensional problems is going to consist of. To sum everything up, your first step, make your gunk tables. Second step, find what equation works. And number 3, rewrite the equation. I know lots of you will think you can skip that step, and if you're advanced, go for it. But if you're just starting out, you're going to want to write the equation. You're going to make mistakes. It's going to happen. And then number 4, you'll plug in your gunk values, and then just solve it. 5 solve. Pretty simple series of events, and once you get used to this, it's just super quick. So that is the most effective way to solve any kinematics problem. And trust me, these last 2 equations will come in handy, okay? So I'm assuming if you're watching YouTube videos, you probably have a test tomorrow, let's be real. Okay, so use these 2 equations, memorize them if you need to, learn the derivation if you need to, memorize this process. It's only 5 steps, and the last 3 are just solving the equation pretty much. You're already used to that. So good luck on your test tomorrow. I know you'll do great. See you next time.